On the morning of December 22nd, 2007, a heavy lift crane vessel off the coast of Guangdong began raising a huge steel structure from the South China Sea. Suspended beneath the lifting gear was a rectangular caisson more than 35 meters long. Somewhere inside it, hidden by mud, water, and darkness, was an 800-year-old wooden merchant ship. The ship was Nanhai I. The main lifting system did not depend on direct attachment to the medieval hull. That was the point. The engineers were not trying to make an ancient ship strong enough to survive a modern lift. They had built a modern steel structure around the wreck, trapped the seabed beneath it, and prepared to raise the entire mast together. The operation looked excessive. A wooden ship about 22 meters long was being recovered inside a steel enclosure far larger than the vessel itself. But that apparent excess was the solution to the central problem. Nanhai had survived for centuries because it was buried. If the wreck were exposed, emptied, and then lifted like an ordinary hull, the recovery itself could destroy what the seafloor had preserved. To understand why anyone would attempt something so complicated, the story has to go back 20 years. In August 1987, a Sino-British salvage operation was working off Guangdong while searching for a different historical wreck. The team did not find the ship it expected. Instead, it encountered evidence of a Chinese vessel buried beneath the seabed. The new wreck eventually became known as Nanhai I, Nanhai No. 1. At first, what made the site remarkable was not a dramatic silhouette resting in clear water. Most of the vessel was hidden. Sediment covered the wreck, and visibility at the site was poor. Divers and investigators could recover objects, but the ship itself remained difficult to see as a complete structure. That burial had created two opposing conditions. It made archaeological work underwater harder, but it also helped protect the lower hull and much of the cargo from continuous exposure. The mud that concealed the wreck had also become part of its preservation system. Investigations soon established that Nanhai I was a Southern Song merchant vessel. Later archaeological dating placed its final voyage in 1183 or shortly afterward. The surviving hull measured about 22 meters long and almost 10 meters at its widest point. Inside were 15 compartments divided by bulkheads, part of the Chinese shipbuilding tradition that separated the vessel internally. The cargo showed that this was not an empty hull lost near shore. Nanhai I had been carrying goods for overseas trade. Ceramics were present in enormous quantities, but they were only part of the load. Archaeologists also found large amounts of iron material, precious metals, coins, and other commercial goods. What they did not find was a reliable explanation for the loss. No surviving contemporary account explains how Nanhai I sank. Storm and overloading have both been suggested as possibilities, but neither has been established as the cause. That uncertainty changes the shape of the story. Nanhai I is not a case in which modern investigators can reconstruct the final minutes from eyewitness testimony. The most important evidence begins 8 centuries later, with the wreck itself. A formal underwater archaeological investigation followed in 1989. Work resumed more intensively in the early 2000s. The site was mapped more accurately. Geophysical survey, diving, and test excavations revealed more of the buried vessel and its cargo. Investigators were gradually defining the outline of a wreck that could not simply be inspected from one clear viewpoint. Some parts were visible only after sediment was removed. Other areas remained hidden. By the time the main recovery plan was being developed, more than 4,000 intact ceramics had already been brought up. Those early recoveries demonstrated both the richness of the site and the danger of simplifying it. A porcelain vessel brought to the surface could be cleaned, cataloged, and displayed. But once separated from the layer, compartment, and neighboring cargo in which it had rested, part of its archaeological information was gone forever. Recovering individual objects proved that valuable material could be removed from the site, but it also exposed the weakness of that approach. An object by itself can tell archaeologists what it is, where it was made, and sometimes when it was produced. But an object still resting in a particular cargo compartment beside a particular group of other objects and within a particular sediment layer can tell them something more. It can help reveal how the ship was loaded, how goods were grouped, and how an ocean-going commercial vessel functioned as a trading system. If the contents were simply brought up one piece at a time, those relationships could disappear. The problem was made worse by the conditions underwater. The wreck was substantially buried, visibility was difficult, and the wooden structure had spent centuries saturated with seawater. A long underwater excavation was possible in limited areas, but exposing the complete vessel on the seabed would remove the very sediment that was helping support it. By the early 2000s, archaeologists and salvage engineers were considering a radically different objective. Instead of excavating the whole wreck underwater, they would move the archaeological site. The plan became known as integral salvage. Its central idea was simple to describe and extremely difficult to execute. A giant steel caisson would be lowered over Nanhai I. The enclosure would surround the wreck and penetrate into the seabed around it. Then, steel support members would be inserted beneath the buried site to create a floor. Once the sides and bottom formed a complete supporting structure, the entire package could be lifted. The crucial decision was what the crane would not lift directly. It would not depend on the medieval keel. It would not ask the surviving frames and planking to carry the full weight of the wreck. It would lift modern steel. The steel would carry the seabed. The seabed would continue supporting the ancient ship. That reversed the usual image of salvage. Normally, mud is something to remove before a wreck can be recovered. Here, the mud became part of the recovery system. The steel caisson designed for Nanhai I measured approximately 35.7 meters long, 14.4 meters wide, and 7.2 meters high. It was large enough to surround not only the known hull, but also a margin of sediment around it. The extra space mattered because the goal was not merely to capture visible timber. The archaeologists wanted the deposits associated with the vessel as well. Planning had begun years earlier, but the project also depended on heavy lift capability. By 2007, the Guangzhou Salvage Bureau had the crane vessel Huatianlong with a lifting capacity of 4,000 tons available for the operation. The first major challenge was to get the caisson down around the wreck. It was an open bottom structure. Lowered from above, it had to be positioned so that its walls surrounded the buried vessel without relying on the ship for support. The walls then had to penetrate downward into the seabed. At this stage, the team was working around a ship it had deliberately chosen not to uncover completely. The engineers, therefore, had to control a structure measured in tens of meters, while the archaeological target remained largely hidden within the sediment below. This was not simply a matter of dropping a steel box into mud. The caisson had to remain aligned with the archaeological site as it descended. Too little penetration, and the wreck would not be fully enclosed. Poor positioning could threaten the very deposits the system was designed to protect. By July 2007, the salvage team had overcome the main difficulties of sinking the caisson into place. Nanhai I now sat inside a steel perimeter, still buried, still supported by sediment, and still largely hidden. But the structure had no effective floor. If the crane lifted at that stage, the steel walls could rise while the wreck remained in the seabed. The next phase, therefore, required something even stranger than placing a box over a ship. Engineers had to build a bottom beneath the wreck without first digging the wreck free. Steel support girders were inserted beneath the enclosed site through the seabed. Progressively, these members formed a supporting floor under the sediment mass. Each new support extended the modern structure farther beneath the ancient one. The operation was not trying to find strong points on the medieval hull. It was creating entirely new strong points outside it. This was the point at which the logic of the operation became physical. The caisson walls defined the sides. The girders formed the bottom. Inside were the archaeological layers, cargo, mud, and the waterlogged remains of Nanhai I. The wreck was not being slung, it was being contained. The distinction mattered because a ship that had functioned as a single strong structure when it sailed in the 12th century could no longer be assumed to distribute forces in the same way after centuries underwater. The integral system avoided making the ancient timber the primary load-bearing element during the main lift. By November, installation of the bottom support had been completed. The open bottom enclosure had effectively become a recoverable container around part of the seabed. Now the entire project depended on the lift. On December 22nd, Huatianlong took the load. The lifting cables came under tension. The caisson began to move upward. There was no need for a dramatic change in the appearance of the wreck itself, because the wreck could barely be seen. The visible event was the movement of the steel enclosure. The archaeological site inside remained protected from the kind of sudden exposure that a conventional lift would have created. What rose with it was not a cleaned archaeological exhibit. It was a mass of modern steel, sediment, seawater, medieval timber, and cargo. For centuries, Nanhai I had existed as part of the seafloor. Now the supporting environment around it was moving too. The caisson rose clear of the sea and was transferred onto the barge Zhongren 1601. The significance of that moment can be easily misunderstood if it is described only as a ship being raised. The surviving wooden vessel had not been pulled directly from the mud and suspended from conventional lifting slings. The engineers had avoided asking the wreck to survive that transformation by itself. They had raised the structure around it. For the first time in roughly 8 centuries, Nanhai I was no longer part of the seabed. Yet the ship was still not fully visible. It remained inside the caisson, surrounded by the same material that had helped preserve it. The recovery had changed the wreck's location without immediately destroying the physical relationships inside it. That was exactly what the method had been designed to achieve. The offshore lift, therefore, solved only one part of the problem. The next challenge was to move an archaeological site into a building. The caisson was carried toward Hailing Island by barge. During the final stage of the transfer, the enormous enclosed mass was moved into the purpose-built Guangdong Maritime Silk Road Museum. The operation used airbags and took about 56 hours. On December 28, 2007, the recovered site entered the museum. It would be tempting to treat that moment as the end of the salvage story. In reality, it changed the location of the work. The museum was not simply a place where a recovered ship could be placed on display. It became a controlled archaeological site built around Nanhai I. The wreck could now be excavated in conditions that were impossible to create on the seabed. That distinction was crucial. Raising the caisson had not produced a finished museum object. It had produced a movable excavation site. The ship still had to be uncovered slowly, recorded, and conserved, and the process would take far longer than the offshore recovery itself. Test excavations were conducted in 2009 and 2011. Comprehensive excavation began later, in 2013. Researchers could lower the water level in selected areas and work through the sediment systematically. Small excavation units were recorded layer by layer. Finds could be mapped before removal. Photographs and measurements could preserve the position of objects that would otherwise lose part of their meaning once taken away. As excavation progressed, the internal organization of the ship became clearer. As more of the hull emerged, one early assumption also changed. Earlier publications had circulated a length of around 30 meters. Full excavation showed that the surviving hull was closer to 22 meters. That difference is a reminder of how much of Nanhai I had initially been inferred through sediment rather than seen directly. The 15 compartments were not simply structural features. They contained the remains of a commercial voyage. Cargo groups could be studied in relation to the spaces where they had been packed. Ceramics that might appear repetitive in a museum display became evidence of loading practice when their original positions were considered. Iron material, coins, precious metals, and other goods contributed different parts of the same picture. Eventually, more than 180,000 objects or sets were recorded from Nanhai I. More than 170,000 were ceramics. Archaeological research also documented about 124 tons of iron material and more than 300 kilograms of silver. The scale of the assemblage also changes how the ship should be understood. Nanhai I was not simply a vessel carrying a few exceptional luxury objects. It was a working merchant ship, loaded with large quantities of commercial material. The arrangement of those goods could reveal choices made before the voyage, long before the wreck became an archaeological site. Those numbers are impressive, but they are not the main reason the integral recovery mattered. The important achievement was that the archaeologists had not been forced to choose between recovering the ship and preserving much of the relationship between ship, cargo, and sediment. They had moved those relationships ashore before dismantling them through excavation. The method was not perfect. Later research noted that vibration during the recovery displaced some small copper objects from their original containers. The caisson did not freeze every artifact in exactly the position it had occupied underwater. But preserving archaeological context does not require pretending that nothing changed. It requires understanding what changed, documenting it, and retaining as much information as possible. By moving Nanhai I as an enclosed site, the team gave later excavation a level of control that would have been far harder to achieve during prolonged work in poor underwater visibility. That success created another problem. A wreck, buried in waterlogged sediment, is supported differently from a wreck exposed inside a museum. As archaeologists removed cargo and mud, more of the wooden hull became visible. The same process that revealed the ship also took away material that had helped support it. And the wood itself could not simply be allowed to dry. After centuries underwater, archaeological timber contains large amounts of water. If it dries too quickly or without proper treatment, it can shrink, deform, and deteriorate. Salts and other contaminants also have to be managed. The ship therefore required continuing desalination, reinforcement, monitoring, and carefully designed support. The central engineering problem had changed. Underwater, sediment had been an ally. It shielded the lower structure, filled spaces, and helped keep the remains supported. Inside the museum, archaeologists had to remove that same material to understand the ship. Every successful excavation step, therefore, reduced one kind of protection while increasing knowledge. In 2007, the question was how to lift the wreck without making the medieval hull carry the lift. After excavation, the question became how to support the exposed hull after the sediment around it had been removed. The recovery caisson, once the solution, now became part of that conservation problem. For years, the steel structure remained around the archaeological site while excavation continued. It had protected Nanhai I offshore and provided a controlled boundary inside the museum. But it was never intended to become the permanent, final support for the ship. Comprehensive archaeological excavation was completed in 2023. Attention increasingly shifted from uncovering Nanhai I to conserving the hull as a complete structure. That required another transfer of support. The old recovery steel could not simply be cut away while the ancient vessel depended on the environment created around it. New supporting structures had to be installed so that the loads carried temporarily by the salvage system could be taken by a more permanent conservation framework. By 2025, removal of the original caisson was underway. New steel support structures were being installed around the surviving hull, while conservation work continued. There is a symmetry in that final stage. In 2007, engineers built modern steel around Nanhai I so the ship could leave the seabed. Years later, conservators built new support around Nanhai I so the old recovery steel could finally leave the ship. The objective had changed again. Discovery had become recovery, recovery had become excavation, excavation had become preservation. Today, Nanhai I remains at the Guangdong Maritime Silk Road Museum on Hailing Island. Visitors can see a vessel that once existed almost entirely as a buried archaeological site. The surviving hull, its internal compartments, and the remains of its cargo have been transformed from something accessible only to divers into one of the most extensively studied medieval Chinese shipwrecks. But the recovery should not be mistaken for a single triumphant moment in December 2007. The lift succeeded because the project treated the wreck as more than a wooden object. The surrounding sediment was not useless material to be discarded as quickly as possible. It was support, protection, and archaeological evidence. The steel caisson was not merely a container. It was a temporary replacement for the seabed. To expose the wreck, they first kept it buried. To move the vessel, they moved part of the seafloor with it. Once Nanhai I reached land, every layer excavated revealed more information while creating a new conservation problem. The decisive lift took place in a single day. Keeping the ship intact may take generations.